Armin Jele is next up.
This order?
This one?
Vor zurück.
Yep.
So, I need my presentation.
Yeah, it should work automatically, actually. So if you press the play button, I hope it works. Yep.
So, yes, correct. So, good morning and welcome to the presentation of AT, Automation Technology, with the title Custom Imager plus Fast FPGA means Galactical Warp Speed. This sounds really like a science fiction, but we do not talk about the future. We talk about our next generation of C6 sensors, and it's still few things are available, and the next are coming soon. And especially with the new imager of C6, the 3070, we reach really high speed, and we say in combination with speed and resolution, we will have the world's fastest sensor in 3D. I will show you a short video to get an impression while I'm introduce myself. So my name is Armin Jele. I'm responsible for key accounts and business development in Europe, and I'm more than 20 years in machine vision and also on the vision trade shows. And yeah, a lot of the time I was at Cognex. And if you look back the last 10 years, there was a lot of things which are changing in 3D imaging, and it's got more and more important. So, and yet all the time I was looking to AT, because AT has what I need in terms for customers and for projects. Yeah, could be more resolution, could be more speed, also bigger field of view. And since 2 years I'm part of AT, and now I have it. Few words for AT. So Automation Technology is located in Bad Oldesloe. This is close to Hamburg in northern Germany. And we are developing, producing and selling special cameras in 2 areas. One of those is infrared. So there we have really robust cameras just for streaming, and also smart cameras where you have an easy job and app concept, and you can do easily your application and a complete turnkey solution. Also some important accessories like our black body is a reference for temperature measurement, and also some enclosures for X area. The second part is non-destructive testing with infrared. There we have turnkey solutions like dashboard check for automotive, or you can inspect the complete airplane in aerospace industry. If you have any questions, you can come directly here to the Hall 10 to our booth. But today we talk about the 3D area. So we have triangulation sensors, and first of all we have 3D cameras where you need a separate laser and you have to make calibration by yourself. We have a big portfolio of compact sensors, so nearly 50 sensors multiplied by different laser options, so it's more than 200 different sensors. If this not is flexible enough, we have our MCS. This is a modular 3D sensor. I will come later to this point. Some magic behind, or some key benefits and advantages of AT, what we already have. So we have resolution up to 4,000 pixels. If you want to measure, if a metrology application, you need accuracy. For accuracy, you need 10 times better resolution. So we have it. We have a big range of field of view from 7 millimeters up to 1.8 meters. Maybe if you have an application, you need today 2 or 3 sensors. You can do it with 1 sensor with a bigger field of view. And we achieve really fast speed. This is 200 kilohertz with our imager 1280. And also we have dual head sensors if you have some issues with occlusions or with shadowing. This is more or less some key facts of the hardware, and also the software is really important because we acquire images, so we have to handle reflections, disturbing reflections that we can do, for example, with our 4-peak algorithm. And also we have some HDR mode, we call it multi-slope. If you have different surface, different material colors, and you have a black part and a shiny part, you already need a good laser line to get a good image. So we do not need to acquire different images with different exposure times. We can handle that quite simple with our multi-slope, and we avoid that the pixels are going saturation, and we get a good laser line and a good image. And this means at the end robustness of the application. As well, we talk about triangulation. Laser is important. We have different wavelength, different colors, and also different laser class depending on application. For example, if you have a multi-sensor application, that the sensors are not influencing each other, you need different laser colors. But also important are things like laser depth of field. If you want to have really a good accuracy in the set range, you need a good standard deviation and less noise for the sensor. So we choose the right sensor with the right depth of field of the laser. Also, laser line thickness. If you want to inspect really small defects, the laser line should be 5 times smaller than the smallest defect. Otherwise, you cannot see it. We have these lasers. And also special focus, calibration, you can do that. And at the end, with our modular compact sensor, you get the right sensor optimized for your application. So the new C6 series, C6 means we have a new FPGA. And for the high resolution, for example, you have double the speed with the new hardware. Here you see some images of the modular compact sensors. What does this mean, modular compact sensor? So this is a customized sensor. Customized sounds expensive, but it's not. So we have no additional engineering costs. We have no minimum order quantity. And the sensor has at least 2 modules. One is the laser module. Is that the green? Oh, there, okay. So, sorry, I want to get back. So, you have a laser, a sensor module, and there is the imager in it. You have the optics, you have Scheinflug, you have mirrors. And the second one is the laser module. And then we have a MCS, we have a configurator, where I can insert in all specifications, like the working distance, near, mid, far field, and especially also triangulation angle. And then you get automatically created the right sensor and the distance between the link module. Could be no link module, could be the smaller ones out of metal, and the bigger ones are a carbon tube. So by the end, you get really the optimized sensor for your application. How this look like? So, one spec, sorry. So this is a screenshot out of our MCS configurator, and especially for the sensor module, you can choose the different imagers from 1280, 2040, and 4090 pixels. Then you can insert the distance, what you need, the target size in width and height, and also triangulation angle from really small 15 up to 45 degrees. Then you directly get, in this case, you see, you can choose a single head or a dual head. In this case, we have a dual head. This means 2 sensor modules and 1 laser module. And you see directly all dimensions, how it looks like. And here you can see exactly the resolution in X, Y, Z, and as well as the profile speed what you can achieve. If you say, yes, correct, this fit all specifications, you press a button and directly get a PDF and a complete data sheet. So, and at the end, you have the best sensor for your application. So these are some examples how it can look like. They can do a lot of things. Some single head, dual head, you see here with the carbon tube. So all is possible. And this will be also available with the C6, with the new FPGA in the future. So talk about the C6, the new imager 3070. We say this is the world's fastest sensor. Why? I don't know if we can start the animation here. So, okay, it's working. So this imager is developed by AT. It will be produced for AT exclusively for sure. And the special thing is, so we are detecting direct on the imager the laser line. And then you can say maybe you want to have 100 or 200 pixels around of this laser line. And only these pixels will be transferred from the imager to the FPGA. It's all on the sensor. And here are some examples. Yeah, maybe you have 10, 20 times less information which are transferred, means 10 to 20 times faster. Some numbers, maybe if you have 3000 pixels here, and by 200 pixels, you achieve more than 31 kilohertz. And for the experts of you, maybe some numbers, You see we have achieved here a profile, a 3D profile of 128 megapixels per second. Or if you know maybe the processing is 28.8 G-pixel per second. It's really fast. And the new imager in combination with the new FPGA, which also brings double speed in combination with the new N-base-T interface, which means 2.5 gigabit per second instead of 1 gigabit, because you have to transfer all data from the sensor to the PC. This is what we call warp speed. Warp is standing for widely advanced rapid profiling. So we say the C6 series, the new FPGA, is the next step, is an evolution. But in combination with the new imager 3070, this is really a revolution because it brings you a lot of speed advantages. This was the hardware. Also we have with the C6 a new firmware, and I want to introduce a few features. So everybody knows, I guess, GenICam. GenICam is a standard Ethernet interface where it's coming from 2D area, and in 2D you just have a grayscale image. And with GenICam we can transfer just 3 features at the same time. With GenICam 3D you can transfer 10 features at the same time, and in 3D, yes, we have an intensity image, a range map, a reflectance map, a point cloud, a scatter map, a lot of more informations which allows you now to transfer at the same time. And our tool for that, it's called multipart. With multipart here, one example, maybe you have a 3D point cloud, you have a reflectance map, you transfer it at the same time to the PC, and then you get a colorized 3D point cloud. Another important new feature is multi-peak. So you know the principle of laser triangulation. You have the laser and you get the reflection direct to the imager. On the imager you get a profile, and then you're looking column by column and you get a peak. Ideally it looks like here, a Gaussian curve, but that's not reality. And with the multi-peak you can handle up to 4 different profiles, means for up to 4 different peaks. What can you do with that? Here's some examples. One is on glass. You tilt the sensor a little bit, but you know you get a profile, a reflectance of the top of the glass and as well of the bottom of the glass. Means you have 2 laser lines, you have 2 peaks, and it's quite simple to measure maybe from peak 0 to peak 1, the distance, and this is the thickness of the glass. So quite simple. Another application is here a V-shaped welding. Yeah, you have a metal part, and yes, for sure, you have a lot of reflection here, disturbing reflections. You get different laser lines, and sometimes it could happen that the disturbing peak here could be higher than the peak what you want to measure. If you choose always the highest peak, you get the wrong information. So with multi-peak, you can handle that. You see maybe peak 0, this is the right one, and peak 1, peak 2, peak 3 could be disturbing reflections. So we just look for peak 0 and you eliminate all disturbing reflections. What does this mean at the end? You get a really good image, you get a robust application, and you don't need to adjust all the time some parameters like exposure time and other stuff. You have a good image and you don't care about that. There are more functions, there are more parameters what you do at the first time, but then it's running really robust. So you can believe it or not, what I told you a lot of things. So we are in machine vision, we can give you some images, we can give you a lone sensor to make the test by your own, to get the same results. You can come to the booth in Hall 10, or we also have some application stories out of the field, some sensors in action. So I hope the video is starting. So one is with our partner SenseWork, and they're doing inline metrology, and you see here there are 4 MCS sensors optimized in the distance, in near, far and midfield. There are 2 laser colors, blue and red, and these sensors are also optimized in depth of field of the laser. So with the software Matrix SDK from Soft Agile, you get directly a point cloud out of 4 sensors, and then you see the image, the point cloud will be compared to the CAD data. And here you saw the green flags, means some important areas. You get really directly the information, and all is in green, it's all fine. If something red, there's something out of tolerance. what you also see here, this is the calibration target. So with this Matrix SDK software, you can quite simple do a multi-sensor calibration and to get one point cloud. And here this is inline methodology, means within 8 seconds they get measured a complete part. These were the old sensors from C5, so it means in the future will C6 be inserted. So it means you can double the speed, so you reach maybe 4 seconds. The next application is coming from Spain, from our partner Syn Systems. You see, hopefully, okay, with sound, it was, yeah, the real factory. You see the robot is putting the parts on the conveyor, and with 4 sensors, with 4K sensors, you can measure the complete part. You also see in this case the sensors are going up and down, always to be in the right focus. So this is also old or first of the machines. In the future, they will use modular compact sensors as C6 with a lot of new tools, and also they can speed up this application. It's too long. Okay. Next video with our partner AKU from Germany, close to Stuttgart. So the application was metal gear parts to measure that in 360 degrees. Really complex geometry, metal parts, reflection, shadowing, occlusions. So they chose 3 dual head sensors, and with the machine vision, with the AKU Vision Manager, this is a framework around. You can easily do the application, and you also have the multi-sensor calibration, means you get 1 image out of 6 images. I don't know, is the video behind? Or yeah, right side, okay, now it's running. So we cannot show the customer part because it's confidential, so they use the calibration part. But you see, it's quite simple to make a complete application with this Vision Manager, and Vision Manager can include third-party libraries like Halcon, like Cognex Vision Pro. Then you have a complete turnkey solution. And last application is from a company Ecomark. So they have, I guess the video will start. Yeah, it's okay. So they have one line, for example, called natural branding, doing marking, for example, of vegetables and fruit. And in this case, they have small parts, and here you see there's a dual head. And what we need is the position, the height, and the angle of the small parts. And then they give the information to the laser, and then the small parts are lasered really accurate. This company is also on the MOTEC in Hall 7, and you can see directly this line. So, I have 2 minutes. So,
quite a lot of questions.
Yes, we have questions, time for questions. So if you have some questions, you can send us an email or can follow me directly to Hall 10.
Or you can ask now. If you have any questions, please shoot your questions now. If not, then I have a question. So on the C6 slide, you said that we get 10 to 20 times less pixel data?
Nope. Yeah.
So that we get higher speeds?
Yes.
Are there any disadvantages of that? So because you're getting less pixel data, are we losing something?
No, because we are in 3D images. So we do need a full frame image of the imager, because we have a small part which is calibrated. And this is calibrated, we are always looking for the laser line only. And then we have a laser line step by step, and we get a 3D image. Okay. So only the laser line is important.
Okay. So
we save a lot of time because we have less information, and then the algorithm running on the FPGA, and then we transfer just this image to the PC. And there we also have some possibility to have an AOI, a smaller area of interest. We have, for example, we have an AOI search and tracking. If the parts maybe are moving a little bit, our AOI is automatically finding the laser line, and you don't need a big AOI, you get a smaller one. It's also a possibility to speed up.
Okay. Good. Thank you so much. Please take a place on the stage.